Okay, so now welcome. Let's do another example. And so I'm going to read it to you. This one's a little different. It says a circle with radius 3 feet is mounted with a center 4 feet off the ground. The point closest to the ground is labeled P. And it says sketch the graph of the height above the ground of point P as the circle is rotated, and then find the function that gives the height in terms of the angle of rotation. Okay, so here's what we have. So we've got a wheel 3 feet where the center is 4 feet above the ground, and it has a radius of 3 feet. Okay, so this is what we're visualizing. Okay, so we've got the ground here. We've got a circle, right? We've got, again, I'm not worried about my sketch here. Okay, so there's point P. And so we've got a circle, and now we've got, this is 3 feet, so the radius is 3 feet. Okay, and the distance here is 1 foot. So it's 1 foot above the ground. And so now we want to represent the path, or the path that this point makes as the wheel turns as a function of the angle. Okay, well that's the starting position. Right? So this would be the reference angle. So the point starts here. So this would be the angle from the starting position. So we're going to basically map this. Okay, so a couple of things that we notice right away. Okay? What's the amplitude of this thing? The amplitude is 3, right? Now where's the midline? Well, if we consider the ground 0, right? Y equals 0. So this is a vertical shift upward. Okay? So we know it's a vertical shift up 4. So we know that D is equal to 4, right? Okay, and the amplitude is 3, so we know A is 3. Now, here's the thing. Now, the lowest point is when the position is at 0, because again, I'm saying this is considered 0 position. It's at the minimum point, right? So it's at a minimum point, and then it's going up. Okay, so at 0, it's at a minimum or maximum point. So that means this is going to be cosine, right? Now cosine usually starts at, the normal cosine theta starts at the maximum point, right? Starts at the maximum point. This is starting at the minimum point. So that means this is going to be inverted. So that means my A is going to be -3. And I'm going to be using cosine. So guess what? My function, just from what I've just been able to gather from this, my function of x is going to be what? Okay, so x is the angle, right? So f of x is equal to -3 cosine x plus 4. And so now what is it going to look like? Well, in this case here, what do we got? We've got, oh, how do I want to do this? Let's do this as, let me, okay, there we go. So now it starts at the lowest point, so it starts at 1. Now the period is still 2 pi, right? So we're going to go from pi over 2, pi, 3 pi over 2, 2 pi. Okay, so it starts at the lowest point, which is at 1 foot, and then at pi over 2, at pi over 2, which is going to be 90 degrees, it goes to what? Well, at pi over 2, it's going to be at 90 degrees from here, so boom. Or how do we want to do this? It doesn't matter. It doesn't matter whether it's clockwise or counterclockwise. So if we do counterclockwise, it's going to be rotated to here, which is going to be then, 4 feet above the ground. So it's going to be, so if we do 1, 2, oops, not that. 1, 2, 3, 4, 5, 6, 7, 8. So here it's going to be up to 4. So, and then at pi, it's going to be at 7, right? So 7 is going to be the maximum distance above the ground. And then at 3s pi, it's going to go back down to 4. And then at 2 pi, it'll be back down to a minimum. So it's going to do something like this. So it's going to start here. It's going to go, oops, like that. And then it's going to continue on over here. So it's going to be 4, oops, 7, 4, 1. So it's going to do like that. And that's it. That's the graph.